Hey guys, and welcome back to a new video in the Spring Boot 4 Basics with Kotlin playlist. I'm Philip, Kotlin developer for the past 7 years, and on my channel you find over 1,000 videos just about Kotlin, Kotlin multi-platform, Android, Spring Boot. So if that's something you're into, make sure to subscribe. In this video, I want to talk about a concept called dependency injection and beans. And what sounds so complex and very often is also overcomplicated is actually not so difficult to understand. Maybe you've heard before that Spring Boot comes with its own so-called dependency injection management. Let's declare that a little bit. A dependency in the coding world is really nothing else than an instance of a class that another class may depend on. So in our case, if we open our quote controller here, then the quote controller itself is a dependency, but there may also be classes in a real Spring Boot project that this controller would depend on. And in the end, those are typically just those class instances that we pass to another class's constructor. So for example, if we have some sort of service here, so I will create a service package, and a service in Spring Boot is really just a class that contains some kind of business logic. So for example, talks to our data sources, manages our list of quotes here. And then we can call this, for example, quotes service. We make this a class. We annotate this with service that comes from Spring Boot, which I will say something about in a moment. So ignore this for now. But in here, we can then really just say the service maybe talks to some kind of data source, which in the Spring Boot world are typically called repositories. So let's also have something like a repository package in here, where we say we have a quotes repository. And this one is annotated with repository. Also, ignore this annotation for now. I will explain it in a moment. And let's say this quotes repository. So repository is really just a design pattern in the software world that has the purpose to talk to one or multiple data sources and properly provide the data. So in the real world, in Spring Boot, this is typically what talks to your remote database, where you implement, for example, your SQL queries in order to get just the data you need. But since in our project, we don't yet talk to a remote database or some kind of persistent database yet, at least, let's just have this quotes repository here implement our logic to maintain our quotes. So in our quotes controller, we take this list of quotes, and we really just put this here inside of our quotes repository, and we kind of treat this as our primary source of data here. At this point, all in memory. So the repository would then have a proper function to load our quotes or get quotes, where we say, okay, that returns our list of quotes. It may have a function to insert a quote, specific quote DTO, where we say quotes.add, and we add this new quote that we passed. It may have a function to update a specific quote. Let me quickly copy this over. Really just exactly what we did over here, but our repository has that single purpose of managing these quotes here together with our data source, which in this case is really just a mutable list at this point. And lastly, let's also provide a function to delete a quote. Delete quote. Pass in the quote ID we want to delete. And then in our quote controller, we can also find this quote here, quote to delete. Also have this in here, try to find the quote ID, and then we would say, if quote to delete is not null, then we remove this quote to delete here from our list. So this is really nothing else than what we did in our controller, just that now we've actually split the contents so that our controller is primarily responsible for handling the incoming requests and deciding about which response to respond with. And the repository has the primary purpose of actually managing the data source and nothing else. The middleman between these, typically in Spring Boot, is a service. So the service would now get something in its constructor, a dependency, which would be our quotes repository. So the service's purpose, and again, we get much more into detail with these architectural layers here later in this playlist, but the service's job is in the end to just implement our business logic. So perhaps if you have multiple repositories, multiple sources of data, where you also need to orchestrate the logic a little bit, get the right data from the right data source at the right time, maybe combine these in some ways. That is what the service layer is responsible for. So here at this point, it's super simple. We really just forward function calls, but it's not how things typically are like in the real world. So here we really may have also functions insert quote, where we say quotes repository. Here we call insert quote with our quote. And maybe let's just also have the other functions. I will copy these here, just not with this implementation, but just with a corresponding repository function. So update quote would therefore call quotes repository.update quote with that quote we've passed, with that quote. And lastly, delete quote will be quotes repository delete quote with this quote ID. And I think we also need a function to get all quotes. So function get quotes would just be quotes repository get quotes. And the list should ideally be private, since just the repository should manage this source of data. But again, just a really, really basic setup here. We have our service layer, which at this point doesn't do anything, just forwards function calls. But I am creating this kind of setup here because you will see this very often in the real world in Spring Boot projects. And this very closely relates to dependency injection and really helps us now to understand this principle. Because now in our quote controller, that is the last part where we now need to actually provide our service. So the quote service in the constructor, and then really just call the service functions. So our quote controller now doesn't actually do any filtering on its own, doesn't manage our list of quotes anymore. But here we really just say we return whatever the service gives us. So our quote service get quote. And yes, I'm aware that we are currently not using this query here. You've understood how to work with these query parameters, so I will just return all quotes in this case. Here we can return our quotes service dot insert quote, pass in our quote DTO, and this function here also must return the quote that has been inserted. So quote DTO, same thing in our repository layer. So quote DTO, and then just return the same quote that was inserted here. Actually, the same thing for the updated one. Here we can return the updated quote, make this a return value. Also here in the service layer, quote DTO, and add proper return statements to both of these functions. Really just to replicate exactly what we had before. And again, little disclaimer, this is still not perfect architecture-wise. We will improve this later, and you will understand why. But for now, this will be completely enough in order to understand dependency injection. So now we can really just have this single function that handles posting a quote and gives us the response that we need in the controller. Same thing for putting a quote. So we can say update quote. And lastly, for deleting a quote, we can say return quote service delete quote. And this previous exception that we've thrown there, we could now throw in our service layer, for example. That is a typical place where we say, okay, if a specific quote could not be deleted, for example, here, we could return a Boolean, whether that was deleted, and then say, okay, here we want to return false, here we want to return true, and we add the return statement. And that allows our service layer to know if this was successful. So if this actually failed, we could then throw something like a quote not found exception and therefore trigger our proper not found response for this endpoint. But what I am actually doing here is I have created a hierarchy of dependencies because our quotes repository as a class is a dependency for our quote service, because our quote service depends on an instance of this quotes repository. And this quote service is again a dependency for this quote controller, because we provide this instance here in the constructor. And whenever we take a dependency here, so for example, this quote service instance, and we pass it into the constructor of, let's say, the quote controller, what we perform is called dependency injection, because we inject this instance of this class here in the constructor of another class. And interestingly, what you can notice if we relaunch this project, you can see it launches and everything just works magically out of the box. So we've declared a lot of new classes here, a repository, we've declared a service. There are different types of classes that these classes are dependent on. And still, we did not instantiate these classes here, so a quote service instance or a quotes repository instance on our own. But still, it somehow magically works that our quote controller, after all, receives the right quote service that it can call all the proper functions on. And this is what I mean with Spring Boot has its own dependency management system. By having all those annotations that we work with here, so service, repository, REST controller, and there are some more, the moment you annotate a class with such an annotation that in the end tells Spring Boot what type of class it is, Spring Boot will register it as a so-called bean. And a bean is really just a component that is managed by Spring Boot, so a class managed by Spring Boot. And the moment Spring Boot registers a class as a bean, it is able to inject this across your project. So it is able to automatically pass this instance of a bean, so the service, for example, inside of a controller here the moment you need it. And this passing happens automatically behind the scenes without us having to do that ourselves. In Spring Boot terms, this is also called auto-wiring. So it automatically wires everything together. And we can also see this if we actually want to register our own type of bean. So we could really just have some kind of test class here, for example, and we say when this is initialized, we print hello world. We did something similar like that, I think before. But if we would now take an instance of this test class, and we would also provide it here in the constructor, so an instance of this test class, you'll notice we actually get a red underline. Because it says could not auto-wire, no beans of test type found. Because for Spring Boot, this is really just a plain class. It is not a class that has been registered as a bean, as something that Spring Boot can actively create and manage. Because in order for Spring Boot to actively create and manage this class, it needs clear annotations. And if a class like this does not fall under a clear category, that it is, for example, a service that contains business logic or a repository that talks to a data source, then we can still register this as a bean by annotating it with component. Just this annotation, and you can see the moment we do this, here the red underline magically goes away, because by adding this component annotation, this will mark this class instance here as a bean. Spring Boot will automatically create it and therefore also be able to automatically auto-wire it and inject it here in any constructor where we need it. So if we now relaunch this, then what we should actually see in our logs is a hello world statement. Because even though we did not create the class instance ourselves, Spring Boot does that, and therefore the init block is called the moment the class instance is created, and we see our hello world print line. And under the hood, both the service and the repository annotation are also just nothing else than components. So they're also annotated with components somewhere behind the scenes. The whole reason why there is also a service annotation and a repository annotation is purely semantic, just to communicate better the purpose of a specific class to other developers. But in regards to actual functionality and behavior about what Spring Boot will do with this class, nothing changes compared to just annotating it with component. So all these three classes are the same type of bean here. Of course, it can happen under certain circumstances that Spring Boot is not able to construct certain beans. Maybe you are actually providing some kind of dependency here in the constructor that Spring Boot maybe knows but isn't able to create. If that happens, then you would get a proper exception the moment you run your backend. So if something with this auto-wiring process fails during startup, then Spring Boot will tell you that with a clear exception to say, hey, I tried to create this type of bean, but I failed because of maybe that reason. Alternatively, what you can also do in order to provide a bean, which you will sometimes see online, is you can apply so-called field injection. So what we did here is constructor injection, because we are using this class's constructor to inject a dependency. But we can also stick to field injection by making a certain property a late init variable in Kotlin. So a variable that where we say, hey, we don't want to initialize that yet. This will be initialized later, but we then also rely on this being initialized when we try to access it the first time. So we could say late init variable, we use our test class here, and then we annotate this with auto-wired. And if we then remove this instance in the constructor, then this will also automatically be provided from Spring Boot at runtime. So we will be able to access this class without having to initialize this ourselves. However, I would typically recommend to stick to constructor injection instead, since it's just the overall cleaner approach and really immediately tells you what kinds of classes a specific class depends on. So let's remove this again, and in general, this test class, that's not needed here. But what actually happens if Spring Boot is really not able to construct a specific dependency? Or let's imagine you want to register a certain dependency as a bean where you want to have additional configuration during that bean creation. Because the moment you actually annotate something with component, Spring Boot will really just automatically try to create a class instance of that. You can see no constructor, so that's easy in this case. And if there would be a constructor, Spring Boot would again look, okay, are there these dependencies registered as a bean in this project? And if so, it would auto-wire these. But what if the specific class instance you have here just requires certain configuration? So you maybe need to call certain functions in order to set it up just in the way you need it in your project. In that case, there's also another way to register it as a bean. And this typically works with a so-called configuration. So here we can create something like a REST config. So the example that I would choose here is to define a bean for a REST template. So if you want to make for example, API requests from your Spring Boot backend to another backend, then there's of course quite some config that we can change for that. For example, connection timeout, how specific errors are handled. And if you want to change something about this REST template, so how these things are handled, then you need to manually register it as a bean. And that works by creating a class, annotating this with configuration, which again is really just another semantic annotation that tells us as developers that we are having some sort of configuration here in this class. But then we can say we define this REST template, which is nothing else than a REST template here. So we now provide a function in which we can create the particular instance of a REST template that we want to use in this project. So also that if we would want to be able to use this here, the REST template, REST template of type REST template, then you can see by default, it's again unresolved, could not auto-wire because we don't have an instance of this REST template, and it also doesn't come from our code. So we can't just change the annotation of this class here because we don't own that code. But what we can do is we can go to our config and say we return our REST template here, possibly change this in some way here with an apply block. So you can see we can define an error handler, a URI template handler, message converters. So lots of things that we could change for this REST template here in this function. And the moment we now annotate this function with bean, Alt enter to import that, this will register the return value of this function as a bean. And in our quad controller, you can see the underline goes away because it's now resolved. And here on the side, I'm not sure if this is really only IntelliJ Ultimate or also in the Community Edition, but you can see really these bean symbols. And if we click on that, we see which bean is being chosen here to inject that corresponding REST template. So here you could then provide some kind of error handler and set this to a response status. What is it called? Not sure what the type of that is. Response error handler, and then have the response here. And based on this response, you could then have some kind of logic where you say, okay, under these circumstances, I consider an API call to be failed. For example, if the body.readBytes, or actually wrap this in use, it.readBytes, decode to string, and if that maybe starts with error. This is something very untypical to do. But if you would want to have such custom config for certain classes, then you can provide this yourself via such a bean function. Now, what Spring Boot will actually use in order to know which bean to inject where is primarily the type information. So if you are trying to inject such a REST template of type REST template here in your quote controller, then what Spring Boot will do is it will primarily just look for, okay, is there any registered bean that has exactly that type of REST template? And if so, that one will be injected. In our case, that's true because we have this provided bean here. There's exactly one of that. So it's pretty clear for Spring Boot that this is the one we're looking for. However, sometimes you have multiple instances per class. How can you now tell Spring Boot which one to inject where? So if we would now have an additional bean that also has this REST template type, and we maybe call this REST template 2, and maybe this one here does not have this specific error handler. So we have two different instances of this same class. And you can see also, we also don't get any error here because there is a REST template. There is a bean that would satisfy these constraints here. If we now launch this, then you can see it still works because Spring Boot still chooses one of these REST templates. So the secondary thing that Spring Boot looks at here, despite the type, so at first it looks at if it can find a clear bean with a clear type. In this case, the type is not clear anymore because we have two beans with the same type. The secondary thing it looks at is actually the name. And because the name of this function matches the name of this field here, of this class instance that we pass to the constructor, it will use the REST template here from this function. If we make this a REST template 2 and relaunch this, then it will use the other REST template that we've provided as a bean. So you will see this will also work, but the moment we actually use something where it doesn't know the name, for example, REST template 3, then we get this error. It says could not auto-wire. There is more than one bean of REST template here, because then in that case, if the name does not match any of the bean functions, then it will use the class type again as a fallback. And we can see, okay, it finds these two types of beans, but a REST template 3 is not defined. So in this case, we could technically add some qualifiers here to give these clear names. But in general, using the function name is already quite solid here. So we should make sure to also properly use the right name here for the right template that we want to inject. Alternatively, what you can also do is, if you really have one alternative template like the template 2 here, you maybe just need this for one class and the other template you need for 10 classes, then you can annotate this one, the primary one, with primary. And then this will always be used as a fallback unless we explicitly provide some other kind of bean name here. So if we use REST template 3 here, then it knows, okay, the primary one is the one we've annotated with primary, and then that one will be used unless we call this REST template too. But that's pretty much most of what dependency injection in Spring Boot is all about, what beans are all about. So we have certain beans. A bean is nothing else than a component, a class instance managed by Spring Boot that Spring Boot is aware of its existence, and which also means Spring Boot can take this instance and inject this all over the place where we just need that instance without us having to create these instances, without us having to pass certain dependencies and class instances to other constructors, but everything in regards to that will happen behind the scenes, managed by Spring Boot. If you enjoyed this, make sure to subscribe to this channel to not miss the next videos of the Spring Boot 4 Basics playlist. And then I can only wish you an amazing rest of your week. I will see you back in the next video. Bye bye.